Good day, grade 4 pupils. Welcome to another Math Amazing episode here in Valenzuela Live. I am your FB Live teacher for today from Andres Fernando Elementary School, Teacher Vic at your service. To recognize your participation in our today's live session, please comment down your name, grade and section, name of your school, and the name of your mathematics teacher. We are now on a quarter 4, week 8 of our most essential learning competencies. For today's lesson, you should be able to express outcomes in a simple experiment in words, symbols, tables or graphs, and explains the outcomes in an experiment. For a short record of favorable outcomes in a simple experiment like tossing a coin, spinning a wheel, let's have an activity. You are going to choose the letter of the correct answer and you are given 10 seconds to answer each number. For number 1, it is an activity that involves chance and in which the result is observed. Is it A, event, B, experiment, C, outcomes, or D, probability? Your timer starts now. Okay, time's up. The correct answer is D, probability. Next number. Number 2, it is a possible result of an experiment. A, event, B, experiment, C, outcome, or D, probability. Your timer starts now. All right, time's up. The correct answer is C, outcome. Next number, number 3. It is an outcome that you want to happen. Is it A, event, B, favorable outcome, C, impossible event, or D, outcome? Your timer starts now. Okay, time is up. The correct answer is B, favorable outcomes. Next, number 4, a set of one or more outcomes. Is it an event, a favorable outcome, an impossible event, or an outcome? Your timer starts now. Okay, time's up. The correct answer is letter A. Very good. And for our last number, number 5, it refers to a measures of the likelihood that an event will occur. Is it A, certain event, B, impossible event, C, probability of an event, or letter D, an outcome? Your timer starts now. Okay, time stop. The correct answer is letter C, probability of an event. Okay, suppose we are going to conduct an experiment by spinning the color roulette 20 times. Then we tally the outcomes using the probability formula. Probability is equal to the number of frequency divided by the number of trials. What observation shall we get? The table shows all the outcomes of a simple experiment. This means that out of 20 spins, the spinner stops at blue 4 times, at orange 2 times, at gray 2 times, at yellow 6 times, at sky blue 3 times, and at green 3 times. Defining experimental probability, it is the actual result of an experiment, while sample space is the set or list of all possible outcomes. Theoretically, the sample space for spinning the color roulette is blue, gray, orange, yellow, green, and sky blue. While the sample space for rolling a die is 1, 2, 3, 4, 5, and 6. The sample space in flipping 2 coins is head and head, head and tail, tail and head, and tail and tail. In order for us to express the probability of each color, we write probability of blue is equal to 4 over 20 or 1 pip. Wherein the expression from our color roulette, since we spin it 20 times, there are 4 blue and 20 is the sample space. For probability of yellow, it is equal to 6 over 20 or 3 over 10, wherein we express as 6 yellows and 20 is our sample space. For probability of gray, it is equal to 2 over 20 or 1/10, where we express as 2 grays, 20 is our sample space. And probability of our sky blue is 3 over 20, where we can express it as 3 sky blue and 20 is again our sample space. Probability of orange is 2 over 20 or 1/10, where we can express it as 2 orange and 20 again is our sample space. Probability of the last color, which is green, is 3 over 20, where we can express it as 3 green and 20 is our sample space. We can express the probability of each color through the following. Probability of blue is equals to 4 over 20 or 1 pip. Probability of yellow is equal to 6 over 20 or 3/10. Probability of gray is equals to 2 over 20 or 1/10. Probability of sky blue is equals to 3 over 20. Probability of orange is equal to 2 over 20 or 1/10. And last, probability of green is equal to 3 over 20. Let us now have an activity. For our activity, I'm going to give a situation. And here's the situation. Rain has a bag of marbles. She removed 1 marble, recorded the color, and placed it back in the bag. She repeated this process 20 times and recorded the result in the table. And using the recorded result in the table, I want you to choose the letter of the correct answer. And you are given 10 seconds to answer each number. For our first number, what is the experimental probability that a red marble will be selected from the bag? Is it A, probability of red marble is equal to 1/4. B, probability of red marble is equal to 1/2. C, probability of red marble is equal to 12 over 20 or 3/5. Or D, probability of red marble is equal to 1. You are given 10 seconds to answer each number, and your timer starts now. Okay, time's up. The correct answer is letter C. Very good. Probability of red marble is equal to 12 over 20 or 3/5. For our next number, based on Rain's experiment, which color is most likely to be selected from the bag? Is it A, yellow, B, green, C, red, or D, orange? Your timer starts now. Okay, time's up. The correct answer is letter C, red. How about for number 3? Using again the table, what is the experimental probability that yellow and red marbles will be selected from the bag? Is it A, probability of yellow and red is equal to 10 over 20? B, probability of yellow and red is equal to 12 over 20? C, probability of yellow and red is equal to 13 over 20? And letter D, probability of yellow and red is equal to 16 over 20. Your timer starts now. Okay, time's up. The correct answer is letter C, 13 over 20. Good job, grade 4 pupils. Now, when we say outcomes, outcomes is a simple experiment, and it can also be presented by a table or graphs. Let's have an example. For our first example, the outcomes in spinning the color roulette 20 times expressed in tables and by a graph. Next, for our second example, Maria tosses a coin 40 times. We can express the outcomes of the experiment in tabular form and also in graph form. On our second example, using the outcomes, we can identify the probability of the head and the tail using the probability formula, number of times an event occurs over the total number of outcomes. Therefore, the probability of the head is equal to 16 over 40 or 2/5. While the probability of tail is equal to 24 over 40 or 3/5. Very good. When someone asks about probability of a coin landing on heads, you would probably answer that the chance is 1/2 or 50%. How many times would you expect it to land on heads? You might say 50% or half of 20 times. So, its theoretical probability is 10 over 20 or 1/2 or 50%. It is said that an event cannot possibly happen and it has probability of 0 or the so-called impossible to happen. Likely to happen if there is an equal chance that an event will happen or not. And lastly, sure to happen if there is an event that an event will happen, then it's probably 1. For our example, number 1, the dog can fly. Okay, so this is impossible to happen. Next, tomorrow will rain. Is it likely to happen, impossible to happen, or sure to happen? Okay, very good. This is likely to happen. Next, number 3. You are in a grade 4. Is it likely to happen, impossible to happen, or surely to happen? Yes, this is sure to happen. Okay, now let's have an activity. Okay, so in this activity, you are going to tell whether the following is sure to happen, likely to happen, or impossible to happen. And you are given 10 seconds to answer each number. For number 1, the sky is cloudy. The sun will not shine. Is it sure to happen, likely to happen, or impossible to happen? Your timer starts now. Time's up. All right. The correct answer is very good. Likely to happen. Next number. Taal volcano is located where Mount Makiling is. Is it sure to happen, likely to happen, or impossible to happen? Your timer starts now. Time's up. All right. The correct answer is very good. Impossible to happen. Next. Number 3. Mount Makiling can be found in Laguna. Is it sure to happen, likely to happen, or impossible to happen? And your timer starts now. Okay, time's up. The correct answer is, of course, that is sure to happen. Next number. Number 4. The sun will rise in the south. Is it sure to happen, likely to happen, or impossible to happen? And your timer starts now. Okay, so time's up. The correct answer is impossible to happen. And for the last number, okay, we have the day after Monday will be Tuesday. Is it likely to happen, sure to happen, or impossible to happen? Your timer starts now. Okay, let us now reveal the correct answer. And the correct answer is very good, sure to happen. All right, great job, grade 4 pupils. Of course, let us remember that experimental probability is the actual result of an experiment, which may be different from the so-called theoretical probability. Sample space is the set or list of all the possible outcomes that we have. While outcomes in a simple experiment can be presented by a table or even by graphs. In development, an event that is not possible to happen has a probability of 0, or the so-called impossible to happen. Okay, for our take-home activity, you may answer the following assessment. Okay, that's the end of our discussion. It is time to entertain your questions, clarifications about the topic that I discussed. Just type it on your comment box. Okay, so we are waiting for some questions. Okay, so here it is. Sir, what is the sum of probabilities of all sample points in a sample space? All right. So the sum of probabilities of all sample points in a sample space is equal to 1. That is always equal to 1. All right, that's all for today. Again, before anything else, let me remind you that probability theory is nothing but common sense reduced to calculation. Okay? Okay, that's all for today. Again, this is Sir Vic Bernales saying thank you, God bless you, and stay safe. See you on the next FB Live session. Bye, everyone!